For this lesson, we're going to be continuing with our discussion of transformations in a quadratic relation. The type of transformations we're going to be talking about today are translations, and that means shifting things left and right, shifting things up and down. And in particular, we're going to be focusing on vertex form. So this is our real first treatment of vertex form, which is the third form of a quadratic equation that we'll be looking at. So in a previous lesson, I looked at another type of transformation, which was called a vertical scaling of a quadratic. And so that could be a stretch or a compression. And related to that is also something, and I think I'll add that in here, is also something called a vertical reflection. And that's when you change the direction of opening. By default, the direction of opening is up. If a vertical reflection occurs, then you end up with a direction of opening being down. And then we have vertical scaling, where we stretch or compress. So in vertex form, the A value has the same meaning as we've previously discussed with respect to vertical scaling and vertical reflections. Then we have this form, x minus h all squared plus k. Now it's important to note this minus h is the default value. So if you have x minus a number, that number is the x coordinate of the vertex. So if you had, for example, if you had x minus 5 all squared, then that means that the x coordinate of the vertex would be positive 5. If you have the y coordinate, it just matches whatever the value is. So another way of saying that, maybe without introducing any numbers just yet, we're going to look at some numbers and some examples. But another way of saying that would be that the vertex has an x coordinate of h. So if this is x minus h, we expect the minus sign there, and that gives us a positive value here. We expect the plus sign here. If that minus sign changes to a plus, it reverses the sign of this. If this plus sign changes to a minus, it reverses the sign of this. Hopefully some examples will illustrate what that means. Okay, so we're going to start with, we have a quadratic here. It is in vertex form already, and we're just going to use a table of values to figure out what these points are. So this is x minus 2 all squared plus 1. So I'll try to make this as clear as possible. I'm going to be putting everything on a single line, just so it fits in my table. So I start off with 0. So that's going to be 0 minus 2 all squared plus 1. And I'm going to do this in a single operation. So 0 minus 2 is negative 2. Negative 2 all squared is positive 4, plus 1 is positive 5. The next one is 1 minus 2 all squared plus 1. 1 minus 2 is negative 1. Negative 1 all squared is positive 1, plus 1 is equal to positive 2. Then we end up with 2 minus 2 all squared plus 1. That one's pretty easy. 2 minus 2 is 0. 0 squared is still 0, plus 1 is 1. Then we're going to do 3 minus 2 all squared plus 1. 3 minus 2 is positive 1. Positive 1 all squared is still positive 1, plus 1 is 2. And then 4 minus 2 all squared plus 1. 4 minus 2 is positive 2. All squared is positive 4, plus 1 is 5. So if we graph this, so that's 0, and then 1, 2, 3, 4, 5. And then vertically, we have 0, 1, 2, 3, 4, 5, 6. At x equals 0, y is equal to 5. At x equals 0, y is equal to 5. So there's our y-intercept. At x equals 1, y is equal to 2. At x equals 2, y is equal to 1. At x equals 3, y is equal to 2. As you can see here, we've come past what must be the vertex, because now we have symmetric points forming. So that tells us that this value, this point, is the vertex. And finally at 4, we have positive 5 on the y. Don't even need to really finish drawing it here, but that's part of this exercise. So nice smooth curve connecting those points. And here's our vertex v. And the vertex, the coordinates of the vertex are 2, 1. So the vertex came from here. Now, let's compare these values, 2 and 1, to the original equation. Y equals x minus 2 all squared plus 1. So could you have gotten that vertex from that equation? And the answer to that is yes. This negative 2, see this is x minus 2, that negative 2 indicated a positive 2 for the x coordinate, and this positive 1 stayed as a positive 1 for the y coordinate. So the sign of this value changes and it becomes the x coordinate. The sign of this value stays the same and it becomes the y coordinate. Okay, so in general, the vertex of the parent function, so that's the one that we first started looking at. It's actually the first quadratic equation that we started looking at. That's y equals x squared. That's the simplest quadratic that you can come up with. So the vertex of this parent function is always 0, 0. If we move the vertex, so if we, for example, change the x coordinate, that means we've shifted left and right. And if we change the y coordinate, we've shifted up or down. So those are called translations, shifting up and down. That's a vertical translation by k units. Don't forget, this is x and this is y. And so if I have changed from 0 to k, then that's a vertical shift or vertical translation by k units. Up or down, we're not going to worry about direction because we actually don't know what sign these are. And a change in the x coordinate by h, that's a left or right, which is known as a horizontal translation by h units. So here's our general equation, and again, I know I'm repeating myself here, just trying to emphasize the idea, what about the signs of h and k? So the sign of h the sign is opposite to expectation. Okay, opposite to expectation. So what that means is that, for example, if I have x minus 5 all squared, that means that my h value is equal to positive 5. So a negative sign gives me a positive, and a positive will give me a negative. For k, it is the same sign. And so, for example, if I have x minus 5 all squared plus 3, this one would give an h value of 5. This one, so that you see I've changed the sign, this one would give a k value of 3. The sign is the same. So this one is the same sign, whereas this one has an opposite sign. And then these two together would give me my new location of my vertex at x equals 5, y equals 3. So let's just practice that idea. Nothing like some repetition to drive a point home. Okay, state the coordinates of the vertex and also look at the direction of opening. Now, in every single one of these, we don't have to think too much about the vertex except for getting those signs right, because everything is in vertex form already. So the vertex in this case, the x-coordinate is going to be the opposite sign, so that's going to change into positive 5. The y-coordinate is going to be the same sign, so that's going to be positive 4. Direction of opening, that comes from the sign of the coefficient in front. Now the coefficient in front here is a 1. More importantly, it's a positive 1, so this parabola opens up. The vertex on this one, we take a look here for the x-coordinate, and we use the opposite sign for the x-coordinate, negative 3. We look here for the y-coordinate. We use the same sign for the y-coordinate, so it stays positive 11. And then we look in front here. Here we have a positive 1, so this one opens up. The next one, opposite sign for the x-coordinate. That becomes a positive 6. Same sign for the y-coordinate. That becomes negative 8. Direction of opening, we look in front. Oh, this one has a minus sign. We actually don't care about this 2. This 2, as we discussed in a previous lesson, this has to do with vertical scaling. But direction of opening just has to do with that sign, and it opens down. Here, my vertex, change the x-coordinate, or change the sign of this for the x-coordinate. That's going to give me negative 13. And this one, the sign stays the same, negative 2. I look in front, again it's a fraction, that just means it's a vertical compression, but it's positive, so this one opens up. And here I have a negative in front. I'll do it in the opposite order this time. This one opens down. And the location of the vertex, this is x minus 4, so the x-coordinate of the vertex is plus 4. This one is positive 5, that stays the same, so the vertex is located at 4, 5. And now, let's identify the transformations in the correct order. So rather than going directly to saying something is a vertex, what we're going to do is we are going to identify the transformations. Now, I'm starting off just with the transformations we introduced in this note. I just want to remind you that in general, if it's in vertex form, x minus h all squared plus k. And when we do our transformations, we are going to read left to right when we do our transformations. So I start here with the a term. In this case, the a term is positive 1. And so that means, and I'm going to put it here, you wouldn't put this, but I just want to make sure it's clear. So since it's positive, there is no reflection. And actually, I really should say no vertical reflection. Now, you wouldn't normally say that. I'm just putting that here. So I'm not going to say that one. And then there's also no vertical scaling, so I don't need to say anything about that. And so what's my first transformation? Now I'm inside this bracket, and this first transformation is this one, but we know it's the opposite sign to that. So that is what is known as a horizontal shift. And what direction? If it's negative 2 in the bracket, that means it actually represents positive 2. So that is a horizontal shift to the right by 2. Now, this word horizontal and this word right, they both, well, I guess I should say the word right implies horizontal. When you talk about something shifting to the left or to the right, that's a horizontal line. So technically, I can actually do without that. That's optional in this case. Another thing you can do to condense that is you can just use the letter H. So you could say that, or you could call this a H shift right by 2. So that's here, and then the last transformation I have here is this negative 3. But this negative 3, that's the k value. The sign stays the same. So in this case, a negative sign, if we're talking vertically, a negative sign actually does mean down. So this one is a vertical shift down by 3. Or I could call that a V shift down by 3. And again, if you just said shift down by 3, that's still clear enough. Okay, so there's an example of how you actually document, how you describe your transformation. So you can see I don't need these ones. I wouldn't include any of those. I would start here with my first transformation. Now, where's the vertex? If we have shifted right by 2, then that means the vertex is at positive 2. If we've shifted down by 3, the vertex is at negative 3. So you can see that these transformations, they line up directly with the vertex. If you know the vertex, then you know these particular transformations. And if you know these transformations, you know the vertex. If we know the vertex, then where's the axis of symmetry? The axis of symmetry, well, that is the x-coordinate of the vertex. It's the vertical line that passes through the vertex. So that's the equation of the line is going to be x equals 2. And finally, the direction of opening. Go back to the original equation. We look at the coefficient in front of the equation and the direction of opening. And this one's positive in front, so the direction of opening is up. How about this one? Now this is kind of interesting. It's not quite what we've seen before. It is in vertex form. Y equals a x minus h all squared plus k. As you can see here, I have an a value. I have an x. This is plus 4, but I still have that form, something in a bracket all squared. But I am missing something on the end here. And so what would I be adding plus what allows me to disregard this? It is plus 0. So no one's ever going to write this, but if you need to think about it, or even if you need to sketch it in there in rough to help you work with it, that's absolutely fine. So now let's look at our transformations. I'm not going to put in those phantom transformations this time. I'm just going to comment on them. So starting from left to right, the sign in front of this is positive, so that means no reflection. So I don't have to say anything about a reflection. Then I run into this 2. Well, that does indicate a transformation. This number 2 represents a vertical scaling. And since this is a number bigger than 1, it actually indicates a vertical stretch by 2. So this one has been stretched vertically by 2. Then we get into this bracket. I have a positive 4, which changes sign when I turn that into a transformation. So that is a horizontal shift. Now if it's going to be if the positive 4 turns into a negative, then that means this is actually a shift to the left by 4. See, normally we think of a positive 4 and you would think that, well, that's plus 4, that would be to the right. But you have to remember that the signs change when you bring it out of that bracket. When you put it into the vertex, the sign changes, and when you think about your shift here. So this one's actually a shift to the left by 4. And then this one is the vertical, but there's no shift up or down. So there's no shift associated with that. We don't list this as a transformation. This plus 0 is relevant, though, when we are asked to find the vertex. So what is the vertex for this? This positive 4 turns into a negative 4. That's a shift left by 4. So it started at 0, 0. It shifted left by 4, so it's at negative 4 now, and it didn't change vertically, so it's still at 0. So another way of describing that would be I could actually say the parent vertex, started at 0, 0. And then what happened to this 0, 0? It got stretched by a factor of 2. Well, that doesn't change anything. It got shifted to the left by 4. That means the x-coordinate went from 0 to the left by 4 to negative 4. We also wanted to know what is the axis of symmetry. That is a vertical line, x equals, and we just use the x-coordinate of the vertex. And then the last thing that we were asked for was what? The direction of opening. And in this case, I have a positive coefficient in front, so my direction of opening is also up in this case. And finally, last example, I think this is the last one. Okay, so again, you might take a look at this and think, oh, but it's not in vertex form. Now, for all of these questions, we've been lucky. I've kept them in vertex form. So again, you might ask yourself, well, hold on, I've got a plus something on the end. I've got a value in front, but this doesn't seem right. So is there a way that I can write this for you to kind of put that into perspective? Negative 0.5. But instead of, is there a way I can write this so it's something squared? Well, what could go in here that I'm allowed to just dismiss and not deal with? What could I add or subtract? Now I'm going to put it in the default form, which is subtract. What could I subtract that has no impact? The answer to that is a 0. So if it helps you, express it this way, represent it this way. And now let's look at our transformations, starting from left to right. Well, the first thing I run into is this minus sign. That means that I have a vertical reflection. The next thing I run into is this 0.5. So 0.5. So here I'm actually going to just do kind of work associated with this second one. 0.5 is the same as 1/2. That is a value. That means that the absolute value of A is less than 1. And so that means we have a vertical compression. By how much? Now, my preference here is whenever you express a stretch or a compression, you put a number that's greater than 1. So this is 1/2, so what I do is I take the reciprocal of that fraction and I say that's a vertical compression by 2. I've talked about this in class before and I've seen this, or you might say a vertical compression by 1/2. I've seen this in textbooks before. I don't like this form. This is my preference, but I have to admit students find it much easier not having to worry about taking the reciprocal of that fraction. The key to this, though, is making sure you understand it is a vertical compression. Okay, now I'm in the bracket. I've got this 0. Well, that's not a transformation. That's not shifted left or right, so I don't list that as a transformation. I get out of the bracket, then I get to this number, this positive 4. That's a transformation. And this one is a vertical shift. And now is it up or down? It's positive, so this one's going to be a shift up by 4. Now don't confuse a shift up with the direction of opening. The vertical reflection determines the direction of opening. The shift up has to do with the location of the vertex. So what is the location of that vertex? The x-coordinate, let's do what I did before. For the parent, the vertex is at 0, 0. So what is our new location? So what has happened to the x-coordinate of the vertex? Well, that's this one, this shift by 0, so it hasn't changed. So that stays 0. What has happened to the y-coordinate of the vertex? It has shifted up by 4. So 0 plus 4 becomes 4. So this is my new vertex. The axis of symmetry is simply the line x equals, and then here I put the x coordinate of the vertex. That's x equals 0. X equals 0 I know seems like a strange vertical line, but that's just the y-axis. There's nothing wrong with that. And then finally, my direction of opening. And in this case, I have a vertical reflection. I've set it in transformations. I can go back and check the equation itself, and I see that the direction of opening must be down. Okay, and that's it for this lesson.